All right, guys, so first up this week is talking about parallel lines. If I were to ask you guys to show me with your arms or with something near you what parallel lines are, most everybody would show me this or this or this. All of those would have been correct. Parallel lines have the same slope, therefore they never cross, they never get closer together. So that's what we're going to be talking about today. The main takeaway from today is parallel lines have the same slope. As you can see here in your notes, those are the two things I highlighted. Parallel lines, same slope. I wanted to remind you of a couple of different equations that we're going to be looking for today. Today we're finishing our equations in slope-intercept form, which is y equals mx plus b, where m is your slope, b is your y-intercept. We're also going to be using our point slope form that we learned towards the latter part of last week. Y minus y1 equals m times x minus x1. We're going to be using that today as well. So hopefully you've copied these down as well as your steps, and we will dive right into some examples. First example that I want to work with you is if we are given the point 2, -3, and it's going to be parallel to y equals -2x minus 1. This is going to be kind of what your assignment looks like today. They're going to tell you it goes through this point, but you want it to be parallel to this line. We just talked about parallel lines have the same slope. So my first step is to identify the slope in this line. So all I care about is right here, because that's the slope. I don't need that -1, that's the y-intercept. All I care about is parallel lines have the same slope. So we're going to use that slope. So m equals -2. We're going to use this point as our x1, y1, and we're going to use our point slope form. Point slope form is y minus the y that they give us equals the slope times x minus the x that they give us. From this point, we can go ahead and simplify using our distributive property over here with our slope. And whenever I see these two negatives side by side, what does that tell us? Great big positive. So we get y plus 3 equals -2x plus 4. One step till I'm finished. To isolate my y, I use opposite operations and combine like terms to give me y equals -2x plus 1. So this equation that we're finishing with is parallel to this line, but it goes through a different point. If we were to graph these two lines, they would be at separate places. They would have different y-intercepts, but they have the same slope, so they would never cross each other. Let's do one more together. I'm going to try to use as much of this first example as I can. So in our second example, let's say that we have the point -4, 1, and we want it parallel to y equals 1/2 x plus 14. Some of you might have already panicked because you're like, whoa, 14 is a big number. But guys, we don't even need it. All we're talking about today is parallel lines, and parallel lines have the same slope. So all we need from this line over here is its slope. What is it? 1/2. So m equals 1/2, and we're going to use that in our x1, y1 to plug into our point slope form. Y minus y1, I about put the x value there, equals the slope times x minus the x that they give us. Now we can go ahead and use our distributive property. If you are not comfortable using this half, you can change it to a decimal, you can change it to 0.5. But guys, let's go ahead and think through it. 1/2 times x is 1/2 x. What is half of a +4? And we get 2. Haven't done anything on this side yet, so we go ahead and copy it down. Opposite operations to isolate our y. Plus 1, and we get y equals 1/2 x plus 3. So, main take home of today. Parallel lines have the same slope. All you're doing today is you're borrowing the slope from the equation that they give you, plugging it in with the point that they give you into your point slope form, simplify, and you're done.